Good morning, everyone. This is your instructor, Wahid Lutfi. I'm going to cover Python regular expression in this lecture, which is Saturday, 4/4/2020. It's 8 a.m., and I'm going to start the lecture today. So I already talked with Cal. We're seeing the screen, and I'll just start the class now. Okay, with Python regular expression, what we are learning today is that regular expression is almost a language on its own, but it is used with Python, Perl, JavaScript, Java, C++, any programming language that you have used, including the operating system like Unix, Linux, they support regular expression. Regular expression has syntax to handle spatial meta characters, and these meta characters have a spatial meaning to the operating system or the programming language that you use. For example, in Python, regular expression that has the anchor, the meta character anchor, which is that backtick kind of symbol, not backtick, actually, the anchor symbol. It is match the beginning of a line, and then the dollar sign match the end of the line. The dot matches any characters. The slash escape sequence, you could have the escape sequence with slash, and then you have a lowercase s means match any white space. And then the opposite of that one, the backslash uppercase s, match any non-white. It's negating the what this the lowercase does. Match any non-white space character. The star means repeat a character 0 or more times. So it may happen 0 times or more times. It's not like a plus. The plus is at least has to match 1 time and then more. So the plus is repeat a character 1 or more times, and the star is 0 or more times. And then the question mark after the star means non-greedy. So at least when it matches the first occurrence, then it doesn't repeat the same thing. That's kind of like optional. If you check the star with a question mark, and if there's the same pattern is matching on the string that you're looking for, the first time it matches, that's good enough. It does not look for more occurrence of it. That's why it's called non-greedy. The same thing with a plus question mark. The plus question mark 1 or more times, but it's non-greedy. And then the set of A, E, I, O, U, in this case, is giving one of those ones. It could happen that either as A is matching, or E is matching, or I is matching, or O is matching, or U is matching. So if you put A or B, A, B, that means A is happening or B is happening. And then the anchor uppercase XYZ set, which is written between brackets, that means that XYZ in uppercase, one of them is not happening, any other character in uppercase, or none of the one in the set. Okay, so the none of the one in the set is negating XYZ. Anything but XYZ in uppercase is not accepted in the pattern. And then A through Z, 0 through 9, that means any characters between lowercase a to lowercase z, and any digit 0 through 9 is accepted. This doesn't mean A and 0 together. It is one character only. That's A or 0, or A or B or C or D until Z, or if none of the A's alpha characters are happening, then it's digits 0 through 9. One of them could happen. Once a 9 is found, for example, then it doesn't check anything. 5 is found, it doesn't check anything. A D is found, it doesn't check anything. And then the other one is indicate where the string character is to start, the boundaries. So the left parentheses and right parentheses is between the starting boundary or a character, a string that is found, and until the end of it. Also with the left parentheses and right parentheses, it says that where the string starts. This is not exactly the slash word boundary. The slash B, backslash B is the word boundary. So it only looks for a word, but this one is looking for a string, starting and ending. And then I have here also a Python cheat sheet that is explaining the same kind of meta characters and their meanings, what they are. This is nice because it also covers the braces. For example, the braces in both Unix and Python and other programming languages, when you put the braces, if you put one number in between the braces means exactly that number. And that syntax is normally M comma N comma M. N meaning is starting with that number, M meaning ending with. So in this case, at 2 comma 5, N is 2 and M is 5, meaning that between 2 and 5 characters of that pattern. And then you put the pattern before that one. For example, if I put A brace 2 comma 5, that means it's going to look between 2 to 5 characters of A occurrence. And then 2 comma, and then not giving an end, which is M in this case, this means 2 or more. That means that the more could be any number of infinite occurrence of that pattern. And then if you miss the first starting, the N, then it is up to the number of M that you put. In this case is comma 5, that means up to 5 characters. And grouping, we already discussed with the parentheses start with and ending with. These other ones are also comparison of P less than Y and then greater than some other pattern that you're going to do these ones. This is regular expression grouping. So once you do the group, then some of the grouping, for example, if you say, if this pattern or string matches the string of if this regular expression pattern matches the string with this condition, then return me the one that I'm grouping with. That's how you do the syntax on it. And then this one is also, we talked about it already. Slash B is backspace character. Slash D is 1 digit. If I'm looking for like 1 digit. And then if I put a plus symbol here, at least 1 digit or more. If I put a star, at least a 0 digit or more. At most a 0 digit or more. So it could have no digit when I put a star. And then one non-digit, the opposite of it is true. We already discussed the backslash S and a backslash. And then there's one character or one non-characters, the W. A lowercase w is one word character and then one non-word character. I'm looking for word, and that's why it's W. These other options are all listed there. You could do it. We already discussed. The one that we didn't discuss is backslash A. Start a string ignoring and ignore M flags. So what the string has to start with start a string with that one. You just put /a and then do that one. But you could use also the $, and also you could do the case sensitivity of that one with pattern regular expression matching. So if you put I, for example, ignore the case, and then these are other meta characters that has a flag that you could put on the flags. Normally, for example, on the regular expression modules, you have methods, for example, called search or a method called find. When we look at those, the syntax of it, for example, on the search and find all, those methods, they require 3 parameters. The first parameter is the pattern. The second parameter is the string that you're looking for match. And the third parameter is a flag. In this case, the flag, if you put I, it means ignore the case. So sometimes case sensitivity, you could just check on that one. And then match any of the line. S is match any line as well. $, start with a line, and then X is allow spaces and comments. L, local character classes, Unicode character classes. Regular expression normally is based on Unicode string and byte. So other types like less than other ones, you don't do regular expression on them. You just convert the less to a Unicode string and then you compare it. Normally, regular expression are against a command line arguments from a pipe. If you're doing it on a Unix or Windows command line, you match for that one, or you do it on inside a Python, you do it opening it in a file, reading a text file, and then doing some pattern matching in that file. New line, okay. Regular expression is spatial characters. The spatial characters, new line, searching for carriage return, form feed, and then octal characters. Let me admit more student. And regular expression replacement. So you could have a replacement as well inside entires. And I'm going to also cover regular expression with Unix operating system or Linux, going through a VM and give you some examples, because aside from Python, you need to know for this class and for other classes how other programming languages like JavaScript, for example, how does that one handle regular expression? What you learned today for regular expression applies to all programming languages. The syntax is much the same. You're not going to memorize too much, but there's a little bit slight different. For example, on Unix, we use a grep command. Grep stands for Global Regular Expression Print. Some people call that one grep as a generalized regular expression parser. And whether you call it generalized or global, it doesn't matter. Whether you call it print or parser, it doesn't matter. But it is a regular expression based. grep has another version. Grep originally was written by Ken Thompson at the time when people back in 1969, when people wanted to work on computers, but the memory on the computer was so small. It was maybe like a meg or something, really, really small. And when they were trying to read a big file in that memory footprint, it was almost impossible to load a file that is size of 2 meg or something. And then how you're going to open a notepad file that is large to read in the memory when your memory is too small. So what they did was they come up with the concept of piping. Ken Thompson, who wrote the grep command, and Dennis Ritchie, who wrote the C programming language, back in the 1969 at the Bell Laboratory, and they come up with the Unix version of AT&T. Both of them, they were just writing these programs to utilities. Now they're on GNU utilities. And then what they did was they introduced a concept of piping. So the input of one command become the output of the second command. And the input of the third command becomes the input of a second command become the output of the third command, and so on. So all they did was piping. And you could see, like, for example, on DOS, if you just do that one on the Unix, is the same thing as DOS. So if I just go here and I say directory, and then I could say directory /s, and it's going to go longer, but I could just say directory /s and pipe it to more. That is going to stop one screen at a time, then I could do that, right? So as I see it, like I could see the file, let's say type, let's say nfile.txt. If I just do that one, it's going to go on the screen, then I could just do more. So the idea of like a regular expression on Windows, if you're looking for nfile, you say type nfile.txt, and then at the same time you say, instead of grep, you say find command /I, mean ignore case. So those are the flags that you're passing, ignore the case, and then I'm saying look for data. If there's anything with data, now it finds those ones. And if I just say look for the symbol at, where's the at? Right here. So it will find those ones. And then I could do another pipe saying that I'm looking only for lowercase from. This time I'm not going to put case, and then I'm going to say this. Now it's there. So the idea was that you're using piping to just reduce the amount of memory that you're loading into the memory computer RAM at the time, to filter it. So now instead of loading 1 gigabyte or 1 megabyte file or something, you're just loading it into a small footprint of what you need to load, and then now it's faster because the memory could fetch it back to the CPU, and CPU process it and then give you the output right away. So it's much easier to look for something and then pipe it and then do it. So the idea of grep command and egrep and then fgrep were introduced. What egrep is, I'm going to start VirtualBox in this case. And the VirtualBox Linux, let's say, I'm gonna show you some of the commands with egrep and grep and fastgrep later on as well. Let me just start Linux CentOS. Okay, so this one is gonna run. I'll leave it on the background to just come up. But on the command line, since I'm running Windows 10 on my PC or laptop, in this case, I just showed you the DOS or the Windows operating system command lines of filtration and pattern matching. So in this case, the pattern that I was looking for was /I and this. Let's see if that example here does the regular expression as well. So if I say start with, it does not support the regular expression find command, but it is the fast regular expression. So what I mean is the fast regular expression is looking for a string, particular string. It only does the string matching. It does not do any regular expression matching. And that's why it's fast. It's based on a fixed string. So the grep command has like 3 different models. Later I'm going to show you. One is called grep command, which is the standard or basic version of grep command that Ken Thompson wrote it back in 1969, 1970s, early 1970. That one, it does global regular expression parser or printing. And the way it does, it just matches for a regular expression, and it does it, and it matches it for a string or a pattern inside a file or inside a piping output, and it is going to return you the result. But the difference between grep command and egrep, which stands for extended grep, that one also basically allow you to do more than just one regular expression pattern, and there's other parameters. So I'm not at this time. I'm not going to explain grep, egrep, and fgrep. Those ones will come up when the Unix is up and running, or Linux is up and running on this machine. I'll show you. But at this time, I'm going to go back to our lecture, which is this one. So we discussed all this. I'm going to go to the next topic on regular expression, and I show you some examples and how we do it in Python. So this is a script that I wrote on Python to just demo on the regular expression modules. This regular expression module is a Python standard library that is very powerful. It does all the regular expression pattern matching. It does all this. So in order for me to show you an example, I already cut and paste the output of the script, everything, line by line, and then I'm going to go to command line. I'm going to show you both from PyCharm. Let me go to PyCharm as well, PyCharm, and from command line. So while that one is loaded, and I have here the screen open. Okay, so in this case, I have a number of regular expression scripts. So I'm going to go with the first one. It's called my regular expression.py. So this one, if you look at the content of it, my regular expression.py, I explain it to you first what it does, and then it's a very simple one. It just set a variable called num to 89 because on a screen you have 80 columns. So I want to do maybe a little bit more than that just to have a nicer screen. And the column could be 120, could be 90, and the size of it. So in this case, I'm setting it to 89. Then I import the regular expression. As we talked in the class, we could import regular expression in a number of ways. So let me just go to and then do another CMD. So at this time, I'm going to just show you an Python interactive also. Let me go to pasadena.edu CIS-012 Computer Information System 012, and then CD to lectures. And then here I have a number of, last week we talked about dictionary, tuples, and object-oriented programming. So I'm gonna go to regular expression syntax. See, right now I'm just using a star, meaning that anything before that one, that's also a regular expression pattern matching. So it knows that I'm looking for something with CD. I put that CD twice, so that is not the right syntax. Okay, now I'm on a regular expression, and then I'm gonna just start Python here. So Python version that I have is 3.74 by default in Windows that I have upgraded. So if I just go here and do a dir. At this time, as you see, I have no modules loaded. Like there's no module called regular expression. So as soon as I say import, let me make this other screen go away so you just don't get it confused. Okay, that's better. So if I do import a regular expression, now I do a dir of regular expression, dir of dir of my all the things that I have. The regular expression is showing on the right side here. That's the module that I just loaded, or the Python regular expression library, or Python regular expression module, you could say. So dir of regular expression shows me all the methods, including the magic method that are like underscore name, or underscore package, underscore version. All those ones are there. But aside from that one, there's like these methods. For example, one of the methods is called search. Another method is called find all. Well, I'm going to show you a couple of these ones that are used the most, and then we can also use the lab to go some of the ones that interest you, and you could practice on those ones as well. And basically, if you're looking for, let's say, the syntax of things, you always use the Python help regular expression dot search, and it tells you the syntax of it, which requires three arguments. The first one is the pattern. Or the pattern could be a pattern of combined a strength, or it could be a byte, or it could be a regular expression. And when you do the regular expression part, let me just tell you first what the three arguments of search is. So the first one is a pattern, the second is the string that you're searching, and the third one is the flag. When you're looking for a pattern on regular expression, the regular expression could be just one regular expression or a combination of regular expression. So you could put regular expression A, and then you could also put regular expression B. Now you have a regular expression, a new regular expression called AB. For example, if you search for the character A, and then but you wanted to just have more than just first you search for A, now it finds it. Now you want to just say, I want to see for the character A at the end of the line. Then you say a dollar sign. Now you put two regular expression syntax into one, or A star, meaning that zero occurrence of A or more of it, or A plus, and that means at least one A or more. So this is syntax of regular expression search. If you look for it, you see it looks for a pattern inside a string, and then the flags. The flags could be just like those one, M, I, X, and so on. I for ignoring the case. And then in grep commands, for example, on Unix, there's flags for I for ignore case, V for just show me everything but the pattern that I'm searching for, and then C for count, the number of occurrence, L for show me the line files, and then some of the regular expression syntax that are on Python not necessarily is going to work on grep command, and some of the commands that are on grep commands may not necessarily work, but a lot of it is the same. A lot of the syntax and the parameters, the type of regular expression pattern that you're looking for is about 80% is the same. What is different is maybe on grep command for a space, you use with single quote space. On Python, you use the \s. So if it is that is the case, for negation of it, you might use the same thing with both of them. You use the anchor to do it for matching the first of the character, you for both of them you use anchor, and then matching to the end of the line is $ for both of them. Dot means one character or any non-white any character but not new line, and then plus means on both of them as one or more occurrence. The star means zero or more occurrence on both of them. And then the question on more on all of them, or just the same thing that saying that optional if non-greedy option. So in this case, if I just do the same thing with find all, notice that find all is doing the same thing, pattern is string flex, but the difference between find all and search is going to look for it and is going to return a match regular expression. Find all is going to find a string and is going to return the result in a list. That's a different way. So now you have the return and you could just do it. For example, let me just show you a quick example. Let's say I say a string is equal, this is a simple test, okay? So I put that, now I say print a string is the same thing as doing this, right? So I see the content of it, but now if I want to say do a regular expression dot search and then look for the word this inside. Notice that if I put this in uppercase, a string, here's the thing that you have to be very careful. So I'm looking for, let me just do a string. I'm going to do this one string 1. Does not make sense to define read because there's already a type a string already, right? And then there's a type integer, there's a type float. These are all the data type that it supports that format. So if I'm just defining my string back to string, that is not good idea. I'm just doing a string 1. So in this case, I'm going to say regular expression dot search. The right format is to put single quote here and when you do the search. But let me try first with double quote to see if it complains. So this is Z and then a string 1, and I don't need to do any flag in this case. If I just do this one, it did find it. So whether you do the double quote like in print statement or single quote, it supports both of them. So when I do search, I do single quote here. That's just a string. So and sorry, close this code. So now it finds it. Notice that the match that was found is called regular expression dot match. So if I just put that one into a variable called m is equal whatever was matched, and then do a type of m, and say that regular expression dot match. Okay. Now notice that at this time it tells me a match, but it tells me an object of 0, 4, meaning that that one started with the index 0, which is the t, and then ended with the index of s, which is 4. So I could just do a string 1 and then put the index like we learned in previous examples that you could do with tuples, with list, and with the string. This syntax of printing it, you just give the indices information and then you get the same value. So if I'm looking for a string 1 and then I say, how about I just do the same thing for simple? Then it's gonna just say now print type m, and then if I just say print them, then it's going to say 1016. So a string 1, 10, 10 and colon 16 will just give me simple, right? So now let's say if I just don't put it in this to just see a faster example, I could do this. And then what if I just put a flag, say ignore case, and it's just complaining about it, says, I don't understand this. Let me just put no flags like that, and is not defined. I is not defined. So it did not understand that flag. That flag has to be a special meaning to it, and we will look into that one for other options like dot operator and other ones. So let's see if we look for the help again. Yeah, that's for fine. Flag is equal 0, and then search. By default, flags is equal 0, and then for search, flag is equal 0. So what if we just do this? Flags is equal I, and I is not defined. Ignore case. So let's see. I put a 1. Okay, so a 1, 0 or 1, and a 1 in this case matched it. It's because I'm looking for case sensitive. Now I'm going to just look for uppercase S for simple. Now notice that a 1 does not, it does, case sensitivity is important. So if I just set that 0 back to 0, it's going to do that one. And if I just take this string, it's not going to return. That means that in either case, that when I just compare for that flag is there. But now if I just want to do it on the regular expression, so this one is not returning. And how I make that one to return, I could put on my regular expression the brackets. The brackets saying that if I just do this one, it's still not going to return. But now I'm going to just say either a lowercase s or an uppercase s, and now it's going to find it. So this is saying that the first character start with either, not start with, the first character is either s, lowercase s, or uppercase s. So if I just have the string 1, now because I made the code to match both cases, and a string 1 has lowercase, even if I just reassign the string 1 to saying that this is a simple, and I write simple and simple like this, simple test. Okay, so I'm thinking a little bit at the same time while I'm writing this. This is a simple test. This is a simple test. Yeah, I have to double code it here. So I do that one, and this string is still going to find it. See, now it finds it with uppercase. Because I'm doing the either match a lowercase s or a match this. But if I just, at this time, if I have the string 1 as this one is all in uppercase, I'll say simple, like this. Now, sorry, double quote, and then now I print out the string 1. Notice that my string 1 now has the entire thing in uppercase. If I do the search with this, it's not going to find it. It's not going to find it, and if I do with the find all, it's not going to find it. So find all is similar to that one, except it returns a list. and then that list, if it founds it, so what if I want to do that one, I say, I'm going to change that one, I'm going to say A through Z, and then this is not going to find it either. All it does is just find out the S and then the first two character. But now I want to just look for the word simple, then I could say this one is going to say this is going to find the entire thing, right? So every time that I'm looking for that word, it's finding that, and then any S is matching there. So if I just do a plus, that's also going to find it. The plus is nicer because it says one or more times. This asterisk is going to match 0 or more times, so at least the S is going to be found here. Now, I restricted with the plus, meaning that it has to have the word S at least once, and then the word I at least once, the word M at least once, and if I just have the same statement twice, let's see if I do this. Okay, I'm gonna say keyword interrupted. Okay, so I go string one, I'm going to say this is a simple test. Doesn't matter what I write on the thing. So right here, you have to be consistent with it. And I'm gonna just say string one. Sorry about that. Okay, so now I'm gonna say this is string. Notice that no matter how many times I did it, as soon as it sees the word that are uppercase, all of them, then it's gonna report in the list. So then I could just assign this one to a list called L1, like we did in the first day of the class. So now I type in print L1, it is the same list that I just returned. If I just look for type of L1, it says that it's a list, right? So it's not a match, regular expression match, it's a list, which means I can traverse through the for loop. I could say for line and L1, and then say 1, 2, 3, 4, print line, and then at this time, I just see the content of that each of the match. And then I could say if match is exact, I could put the if statement. If, for example, let's say I could say something like this, and then say, and instead of print it, I don't want to see the ST. I could do another expression, a regular expression, say regular expression dot search, and then I could say simple. So I could say simple, and then on the line, I'm going to put a F statement here. If that is the case, then print it. Print line. So in this case, I'm going to have to do 4 more indentation. 1, 2, 3. Sorry, 1, 2, 3, 4. Print line. Then it's going to just print only the 3 that I want, not the ST. Okay, so let me just show you now the script that is there. We went through the regular expression and there, and then notice that all I created these one string one and a string, and you could just do the type and help on those ones and see the modules that are available. For example, dir of a string one is already going to show you what are the method and what you can do with those ones. Left stripe, right stripe, all those other ones that you could do, splitting, finding it, and so on. So I'm going to exit out of this just for now, and then I'll show you the more um, my regular expression.py. So in this example, I'm going to just print some lines to just give you a better look for it. I'm running a dir, let me admit more student. Okay, so I'm doing a dir of regular expression, which we did. It shows you a lot of the details for it. And then help also on the regular expression, it gives you the syntax, which we will look into it. And then type, what type of regular expression it is, and the find, and then the search. And then in this case, I'm looking for, and this is string one, this is a simple test, and the word that is either a T or an uppercase T. So this one, whether it's lowercase t or uppercase T for the first word des is going to be found. And if I put a anchor, then that means it has to start with the. There's a method also in Python called the start with, but the reason you put a regular expression comparing to some method that is already say start with or $ ends with, you find a method. You don't want to run one method 10 times when you're looking at 10 different matching. And then there are situations that you're dealing with regular expression with dot star or dot plus, which means one or more occurrence of any characters or one or more of that one. If you have to use a method 1,000 times, it would be ridiculous. So you don't want to do that one, and then nobody does that. That's why the power of regular expression comes in. All you do is do a certain pattern matching, and based on that pattern, it just automatically happens. Regular expression is a very good timing for you to understand because, for example, like with COVID-19, if you're looking for some sort of pattern for all the cases that so far has happened, the 1 million cases that happened, 100, it's 1.2 or 1.1 million as of this morning. That number of cases that has happened, if we had collected some data of how people got infected to begin with, where it was not social distancing, or whether they typed something, or whether it was in the environment, whether it was getting from a family, whether it was getting from a supermarket, a restaurant, whatever the person reported that this is how I got infected with COVID-19, then if we collected that data on a computer, on a database that is widely accessible by all the hospital, that they could just log into the database and just enter the data saying this person was infected this way. Now you could write a program in Python, for example, or Unix, or any programming language, Java, JavaScript, C++, or in this case, if you write it in Python, the regular expression that you're matching for saying that case the issue happened at home, the regular expression that you're looking in the data file for home, for the word home, and then right away 1,000 cases gonna just report. And then you look for another pattern that happened in the hospital, happened at the work, happened at some place like restaurants. And then all of a sudden, you see the majority of the cases when you time it out and write some other function to just calculate the average of the median, and then all those kind of calculation that you could do to do some data science or data analysis on the big data that you collected. At this time, you report it into like another um, kind of like XML file, text file, database file that just shows a report of the statistics of how people got infected. And then based on that statistic, now you have a nice pattern. And then you say, well, out of the 1.1 million, so for 50% of it was happening because they didn't do social distancing. So now here's a solution that social distancing definitely could help. It is a very, very easy solution to the problem if people just think about it and try to come up with some kind of pattern. And then if right now NASA and a lot of other companies are already working on the supercomputers to just figure out some solution to the problem and come up with maybe some sort of resolution to the problem. A lot of other companies are trying to come up with the vaccine, but the vaccine, if it is too far, too long, at least let's try to mitigate the problem. Let's try to figure out what could be the root cause of this. What is affected more people than everything else? As soon as we find out the root cause of it, that is maybe 80% of people are infected because they're not doing social distancing, then we enforce the social distancing. It's not right to just know the problem is could be at least mitigated, and nobody just knows what is the solution to mitigate it. So at this time, the regular expression, I'm showing you these ones. You could even think about it and write something, and maybe it might be someday that one of you just guys are going to discuss it, or gave the idea to somebody else that who could listen to you. Because Bill Gates, for example, 4 years ago, he talked about it, that something like this happened. Back in 2000 to 2005, I had a website. I was writing a lot of the website called mywebuniversity.com. And at that time, I was just like trying to make sure that the students could go to this site, and then if they are studying somewhere outside of their state or outside of their country, they could find a university or school that they're interested. So I had millions of websites for documentation on millions of schools that are not millions of a school, but millions of links to schools like UCLA, Berkeley, Stanford, Oxford, all those universities, Cal State Fullerton, Pasadena.edu, and all those other schools that are providing some sort of classes online or outside physical face-to-face classes, but a student could know about the financial aid program on that school, so they don't have to travel to that state or that country in order to get this data. And at that time, I was really much interested to work on big data about data, right? Metadata. So I was interested to do those ones, and unfortunately, that website, I built it, and then the web hosting company that I was working on, they just had issue with their control panel, which means that their Apache web servers were hacked, and they just did not maintain it. So at that time, I just transferred the whole website to home, and I rebuilt the website because a lot of the database, everything that was supported on their control panel was no longer available for me. And they had on a different platform, I had to convert it. So I built the website again. And as you had seen it already with mywebuniversity.com, it has now about 1 million, not 1 million, 100,000 technical documentations on Unix, Linux, Macs, Solaris, Windows, and PowerShell. Why I'm talking about that website? Because in 2000 to 2005, while I was discussing a lot of things about the big data, I put this idea of someday we're going to be hit with pandemic kind of diseases. already were seeing AIDS and SARS, and not SARS at that time, but we were seeing AIDS, and a lot of people were dying of cancer. But I was saying that these big companies like Google, like mywebuniversity.com was also almost like a search engine. I was saying that at that time that people could come up with some solution to this pandemic diseases by searching inside these big data. That when you look on the big data, that you're finding out pandemic kind of diseases, and then you find the pattern. It's much easier to just go to like the big data that Google has, the big data that Facebook has. A lot of these data that they are collecting is based on social media, and then a lot of people are using it. Now there's a lot of data that you could search for certain pattern. Now 5 years ago, the data science was introduced, and you're using Python programming language. It does a lot of data science, the kind of like programming that supported. And this pandemic of COVID is one of the data science things that we could do. So the idea, what I'm saying about what I told everyone on the website about 20 years ago, is introduced by a lot of people everywhere in the world, that they say something. Unfortunately, the people that they have the power, the technology, the hardware, the software, the money, they are not working on it unless they just see their own interest on it. And the people are less working on what human are supposed to be, or looking for the environment and the other ones. That has to be our priority number one. The people that they are working on money and stock market and oil market and all those other ones, that should be a second option. The first option, how we help the human society to grow, to be more healthier, to be safer, and to live longer. And I think that one,